Now we continue looking at matrices. We have looked before at types of matrices. We looked before at adding matrices, and we looked before at multiplying matrices by a number and multiplying two matrices. Now, we want to look at a few things here. We'll look at these without proof. We're going to use the algorithms and the formulas to work these out right now. Proofs can be dealt with in further mathematics studies, but for now, we look at the determinant of a matrix, the singular matrix, the adjoint matrix, and the inverse of a matrix. So, let's go. Now, the determinant of a matrix. We have this matrix A equals. We have the elements in the matrix A, B, C, D. Now, we want to know what the determinant of this matrix is. You can say the determinant of A equals the determinant of A is so and so. You don't have to write it out like this. You could put DET A equals. You could also say that means the determinant of A equals. That is one symbol you could use. Another symbol is this. You have your A, your B, your C, your D. That means the determinant of this matrix with the vertical lines on both sides means the determinant of. You see that? Now, what is the determinant of A? The determinant of A is, listen carefully now. You're going to multiply the leading diagonals, then minus, then you multiply the elements in the non-leading diagonals. So it is the product of the elements in the leading diagonals minus the product of the elements in the non-leading diagonals. So ensure you get that. So, how that works? It is A times D. You multiply the elements in the leading diagonals minus multiply the elements in the non-leading diagonals. This minus C times, let's put it in alphabetical order, minus B times C. So it's AD minus BC. Do you see that? That is the formula for calculating the determinant of the matrix. Alright. Now, I want you to calculate the determinant of B. 5, negative 3, 8, and you have 6. What is the determinant of B? I know you will enjoy working it out, and you will even enjoy it more if you get the right answer. So go right ahead. Okay, you've done it. You have done it. So let's see what the determinant is of B. You multiply the elements in the leading diagonal. So you have 5 times 6 minus. Then you multiply the elements in the non-leading diagonals. So you subtract negative 3 times 8. So this is 30 minus negative 24. You'll remember that this is 30 plus 24, and your answer should be 54. So the determinant of this matrix is 54. Hope you get that. Alright, let's look at another example. We have another matrix. Suppose you call it C. This is our matrix. Alright. So you have 6, you have 3, you have 10, and you have 5. That is your matrix. Calculate the determinant of that matrix. Go right ahead. Have you finished? Good. Let's see. The determinant of C is, you multiply the elements in the leading diagonal. So it is 6 times 5 minus. Then you multiply the elements in the non-leading diagonal. And you have 10 times 3. 6 times 5 is 30. Minus 10 times 3 is 30. What do you get for the answer? Well, in this case, you get a 0. Now, the determinant of this matrix is 0. This type of matrix is what you call a singular matrix. Right? Determinant equal 0. The determinant of a singular matrix is 0. You see that? Nice. Next, there is what is called the adjoint. The adjoint matrix. Now, we want the adjoint of A. What we say is A adjoint. You could spell out the whole word, but the adjoint of A is. What you're going to do to find the adjoint of the matrix, you interchange the elements. Make a note of it carefully. You interchange the elements in the leading diagonals and multiply the elements in the non-leading diagonals by -1. So their signs change. So in this case, the adjoint will be A times D. You multiply the elements in the leading diagonals. Oh, not multiply, my error. You interchange, not multiply. You interchange the elements in the leading diagonals. These will change place. So, what you will have is D coming where A was. A will go to where D was. That's it for that part. Remember, as I said before, you interchange the leading diagonal elements. Then you multiply the elements in the non-leading diagonals by -1. So they don't move. B remains where it is, but it's now a negative. C remains where it is, but it's now negative. Alright? That is the adjoint of the matrix. Now, let us see what would be the determinant of the adjoint of A. Is it going to be the same as this? Let's see. If you multiply D and A, if you multiply the leading diagonal elements D multiplied by A minus -B times -C, what do you get? This is the same as DA is the same as AD. So that is AD minus, when you multiply -B and -C, you get a positive. So it's B multiplied by C. So it's the same determinant that they will have. You see that? So now, we've looked so far at the determinant, the singular matrix, and the adjoint. Make a note of it. But now let's look at the formula for the inverse of a matrix. Now, we want A inverse. Instead of writing out INVERSE, you do this, just like you do with numbers. Now, what is the inverse of the matrix A? The formula for it is 1 divided by the determinant. You see that? It's going to be the determinant of A, which is AD minus BC multiplied by the adjoint. Alright? It's going to be D -B -C and A. So this is the formula for the inverse of a matrix. Very beautiful. I have to put it in a box and Griff wrapped it. That is a nice little formula that we are going to be using. And we will use this formula to calculate the inverse of matrices in our next video. So stay tuned.